Problem 25, we're supposed to graph the system of inequalities. So in order to do that, there's a couple steps we need to take. First, we need to draw the lines that would go with the equations that go with the inequalities. We can do that by finding the x and y intercepts. Then we need to determine what type of line to use, whether it should be dotted or solid. Then we need to figure out what side of each line we should shade using a test point. With a system, we're looking for where our solution regions overlap. So first we'll graph the line x plus 2y equals 8, and we can get that graph by finding x and y intercepts. So the x-intercept is the value for x when y is equal to 0. So I'm going to take that rule and plug in 0 for y. That gives me x is equal to 8, and so that gives me my x-intercept, where to plot a point on the x-axis. I'll repeat the same process for the y-intercept. Y-intercept is the y value when x is equal to 0. So now I'm going to take the same rule and replace x with 0. That gives me 2y equals 8. Divide both sides by 2, and I get y equals 4. That tells me where to plot the point on my y-axis. Once I have those 2 points, I'm ready to connect them, and I need to figure out what type of line I should use to connect them. And we determine that by looking at the type of inequality symbol that's being used. In this case, the symbol does not have a line under it, so we would use a dotted line to connect those 2 points. Then we need to figure out what side of that line we should shade, and we can use a test point in order to do that. Test point can be any point that's not on the line. This line does not go through the point 0, 0, so that would work fine for a test point. Take that inequality and plug in 0 for x and 0 for y, and then simplify and see what your result says. So this says 0 is less than 8, which is true. So the side of that line that contains the test point is the side that we want to shade. Now we need to repeat the process for the second inequality. We'll start by finding the x-intercept. Plug in y for 0. And if you solve for x, we divide both sides by 5. That gives us x is equal to 2. So on the x-axis, I'm going to mark a point at positive 2. Now I'll find the y-intercept, where we plug in 0 for x. That gives us a result of negative 10. And so on the y-axis, I'm going to put a point where negative 10 would be. Now I need to figure out what type of line. This is going to be a dotted line, since again there's no line underneath the inequality symbol. And finally, I'm going to use my test point in order to figure out what side to shade. This line also does not go through the point 0, 0, so that would work fine for a test point. Plug in 0 for x and 0 for y, and we get a statement that reads 0 is greater than 10, which is false. So with the purple line that I drew, I do not want to shade the side that contains my test point. I want to shade the other side. The area where the two colors overlap, that's our solution region. Problem 26, we're given another system of inequalities to graph. We're going to repeat the same process that we did for number 25. We're going to start by graphing the first inequality. We'll find the x-intercept by plugging in 0 for y. That gives us a positive 3 for our x-intercept, so we'll mark where positive 3 is on the x-axis. Next, we'll find the y-intercept, so we'll plug in 0 for x. That gives us a value of positive 4, so that tells us where to mark on the y-axis. Now figuring out what kind of line. This time there is a line underneath the inequality symbol, so we would use a solid line to connect these points. Next is to figure out where to shade. This line does not go through the point 0, 0, so that's a good point to use as a test point. So we'll plug in 0 for x and 0 for y. We get a statement that reads 0 is less than or equal to 12, which is true. So we'll shade the side of the line that does contain the test point. Then we'll repeat the process for the second inequality. First we'll find the x-intercept by plugging in 0 for y. We get x equals negative 9. So on the x-axis, I'm going to mark where negative 9 is. For the y-intercept, we'll plug in 0 for x, and we get a value of 3. So on the y-axis, I'm going to mark where positive 3 is. This time we need a dotted line because there's no line underneath the inequality sign. Again, we can use 0, 0 for our test point. So plugging in 0 for x and 0 for y gives us a statement 0 is greater than 9, which is false. So for the black dotted line, we don't want to shade the side that contains 0, 0. We want to shade the other side. Where our two regions overlap, that's our solution region. Problem 27. This time we're just supposed to graph the line 6x minus 3y equals 36. We can do that by repeating the same process that we did at the very beginning of the process for the previous two problems. So first we'll find the x-intercept by plugging in 0 for y. That gives us a value of positive 6, so I'll mark where positive 6 is on the x-axis. Then we'll find the y-intercept by plugging in 0 for x. That gives us a value of negative 12 for y. Now on my graph, if I was counting up by a scale of 1, negative 12 wouldn't be on this grid, it would be beyond it. So on my y-axis, instead of counting up by 1s, I'm going to count up by 2s. That way I can go ahead and fit the point negative 12 on the grid that I've been given. And now I just need to connect those two dots. This time I don't need to worry about dotted or solid, and I don't need to worry about shading, because those two things only happen if you're graphing an inequality. This time we're graphing an equation, so all we need is a solid line and we're done. Problem 28. Some of you might have a typo on this problem. There was accidentally two x's there where there should have been a y. So the equation is supposed to be negative 2x plus 7y equals 14. We'll graph this using the same method as the previous problem. Start by finding the x-intercept when y equals 0. That gives us a value of x equals negative 7. And so we'll plot where negative 7 is on the x-axis. Then we'll find the y-intercept by plugging in 0 for x. That gives us a value of y equals 2, so we'll mark where positive 2 is on the y-axis, and then use a solid line to connect those points. Problem 29, we're graphing an inequality this time, so we'll start by finding the x and y-intercepts, but then we'll need to figure out what type of line we need and what side to shade. So we'll find the x-intercept by plugging in 0 for y. That gives us positive 9 for x, and so we'll mark that on the x-axis. Then we need to find the y-intercept by plugging in 0 for x. That gives us y equals negative 3, so we'll mark where negative 3 is on the y-axis. Now we need to determine what type of line to use. The inequality symbol has no line underneath it. It's only greater or less than, it's not equal to, and so we'll use a dotted line to connect those 2 points. And now we need to figure out what side to shade. This line does not go through 0, 0, so using that as a test point would be fine. I'm going to plug in 0 for x and 0 for y, and I get a statement that reads 0 is less than 9, which is true. So the side that contains 0, 0 is the side that I want to shade. We have another inequality to graph. 5x plus 2y is greater than or equal to 20. We'll start by finding the intercepts. Find the x-intercept by plugging in 0 for y. That gives us a value of 4 for x, so we'll mark that on the x-axis. Then we'll find the y-intercept by plugging in 0 for x. That gives us a value of positive 10 for y, so we'll mark positive 10 on the y-axis. Now we need to determine what type of line to use. This time there is a line under the inequality sign, so we need to use a solid line to connect those dots. And last, we figure out where to shade by using our test point. Again, this line does not go through 0, 0, so we can use that as our test point. Plug in 0 for x and 0 for y, and we get a statement that reads 0 is greater than or equal to 20, which is not true. So we need to shade the side of this line that does not contain our test point.